So Logan, let's pretend to be bricklayers here today, okay? So we've got our brick, we've got our rock made out of clay minerals. Why don't we go ahead and start to stack our bricks? So you've stacked a brick now on top of this brick below, and stack another one, okay? So do we think this happens in nature?
I'm not sure.
Well, it does happen in nature, actually. So rocks get stacked over sometimes millions of years, sometimes in just one season. But what separates them is the order in which they're deposited. Which brick was laid down first?
This one, the bottom one.
The bottom brick was laid down first. Can you build a brick wall from the top down?
Nope.
Why not?
Because gravity.
Because of gravity, that's right, yeah. And so in order to build that brick wall, the masoner has to start at the bottom and work their way up. In nature, the same thing happens. Rocks that are formed first, or the oldest rocks, form on the bottom. So if we laid down that brick first, if the bricklayer puts that first layer of bricks down, what can we say then about this top brick?
It's the youngest.
That's right. And so even in nature and geology, the oldest rocks are typically on the bottom, and the youngest rocks are on top. We call that a principle of superposition.
So in nature, as the layers of sediment stack, the heat and pressure compresses them together so they're solid. In this, we're going to be using the mortar to keep the bricks together to represent that.
Well, that's very good. Yeah, and in fact, the fluids that are buried with the rock contain minerals dissolved within them. And so they form a type of cement which holds the grains together in these layers. Just like a masoner would use cement to hold these bricks together. So we're just going to create a layer of cement on each of the bricks. And that will hold them together and essentially form a complete layer of rocks. So we're going to take the top brick and stack it on, and now we've got a continuous sequence of rocks. Now imagine I'm at the bottom of an ocean, and these rocks have been buried deep underground. And the cements within this rock harden. Other things can happen to these rocks later. They don't always stay flat lying like this. Can you think of things that could happen to these rocks later on? Think about things like earthquakes or even mountains building. What could happen to these rocks?
They could break, they could merge together.
They could.
If the tectonic plates are colliding,
Ooh.
They could, split apart.
Yeah, no, all of that is right. First thing that could happen is they could not be horizontal anymore, right? Can you help me by tilting these up? So let's hold them together and just kind of tilt them up on their side. So sometimes if you go out to a mountain, the rocks aren't always flat lying, are they? Sometimes they're tilted like this.
Yes.
Okay. Now let's assume that this is dry, and it's not. But what would happen if, say, there was a large earthquake? Could it break the rocks?
Oh, it would break. Yeah, they'd break in half.
I think we should probably need to break some rocks then, don't you?
Yeah.
All right, let's get your glasses. Go ahead and put those on, just to be safe, because I'm in the mood to break something, aren't you?
Yes.
All right. What we're going to try and do is break at least this top couple of bricks in half, okay? So I want you to hit right in the middle. Pretty good. There you go. Perfect. So what have you done there?
Well, I've caused a small earthquake.
You did, and it actually caused the rock to break, didn't it?
Yep.
Now, did it break the rocks underneath?
No.
No, it didn't. But let's let's go ahead and take these off, and let's go ahead and break the rock underneath, okay? Go ahead. There you go, perfect. Yeah, we cheated, right? That's okay. So let's say that those rocks did break, so some event happened. Some earthquake occurred. Now you see this fracture that's running through the rock, right? Is that fracture younger than the rock or older than the rock?
Younger.
Why is that?
Because it just happened.
It just happened. Could we have made a crack if we didn't have a rock to begin with?
No.
No, not at all. Not at all. And so we can not just date the rocks in relation to each other. We can date the things that happen to rocks.
Yes.
You happened to this rock.
Yes, I did
several
happen
times.
to this rock.
So let's say, for example, something else happened. Let's say there was another mountain building thing that occurred, okay? Let's remember we talked that we could tilt these?
Yeah.
What happens if we tilt these all the way over like this? Now are the rocks horizontal anymore?
Nope, they're vertical.
So if I was a geologist and I saw vertical rocks like this, and I thought, rocks are usually horizontal to start with, what's the first thing I think must have happened?
They must have moved vertical.
Yeah, they must have turned. They must have moved. Okay. So that is exactly what happened, right? And let's say these were eroded. Let's say some erosion occurred here. All right, and came along and removed the top layer of rock. Go ahead.
There it is.
There you go, perfect. Okay. So let's kind of recap what all's happened to this rock up to this point. You remember what the first thing was that happened?
It broke.
Even before that, we had to bury a rock. We had to make a rock. And what was the rock, horizontal or vertical?
It was horizontal.
It was horizontal. And then what happened after that?
Then we stacked them.
We got more rocks stacked up, and they were cemented together, right?
Yep.
Then what happened?
Then they were split in half by something, earthquake, my hammer.
Yep.
Could be anything.
Could be anything. That's right. And then once the rocks were broken, now what orientation are they in?
Now they've been moved vertically.
That's right. So now they're vertical. So lots of things have happened to these rocks. But a geologist could come by and actually work backwards and use these as clues to figure out the history of the rock, right? So one last thing needs to happen to these rocks. Okay, what have we got now? I said that let's pretend that this was erosion, that this is the surface of the earth. Remember what erosion does? Wind and water and ice essentially remove the rock from the surface. What if an ocean flooded this surface and all of a sudden I could now get new rock deposited? Why don't you grab some cement? Okay, we'll grab a brick. You got the right idea. Grab some cement.
Okay.
And let's just put a layer right down on top of these three pieces. Yeah, that's great, yeah. And so now sometime later, grab one of these tan pieces, yeah.
Cool.
So sometime later, what happens if a new horizontal rock is laid down on top? Right?
Yeah.
If this was an ocean and these were older rocks and this was a younger rock, they'd be laid down originally horizontal. And that's one of the principles of geology. So when we see a horizontal rock, we can assume, unless something crazy happens, that it was originally that way. Yeah. So what do you think? Do you think we've built a good model of the principles of geology here? And
yeah, this is a very good model.
yeah.